Welcome to our project presentation. Our project is the Solar-Assisted Mechanical Water Purification Unit developed by Aquamech Builders. This project was completed by Malik Mahmood, Mohammed Khaled, and Ali Mohammed under the guidance of Dr. Ayman Abbas. Our design addresses the challenge of providing safe drinking water in remote and harsh environments. The idea was inspired by the urgent need for clean drinking water in military operations, especially in deserts, remote areas, and emergency situations. Traditional purification systems often depend on electricity or fuel, which may not be available in the field. To solve this challenge, we designed a sustainable, low-cost system that combines solar sterilization with mechanical filtration, creating an independent and practical water purification solution. Our project is a portable water purification unit designed to improve water safety using renewable energy and mechanical engineering principles. It consists of several main components, including a manual hand pump, control valve, multi-stage filtration system, and supporting frame. Together, these components create a reliable system capable of purifying contaminated water without external power sources. The exploded view animation highlights the assembly process, illustrating how each subassembly integrates into the complete structure. The unit operates through a step-by-step purification process. First, contaminated water is introduced into the system and pressurized using the manual hand pump. The water then passes through the solar-heated chamber, reducing harmful microorganisms before entering the filter. Inside the filtration system, multiple layers, including activated charcoal, gravel, sand, fabric, and cotton, remove impurities and improve water quality. Finally, the clean water is controlled by the valve, which regulates its flow out of the filter. The motion study demonstrates the dynamic functionality of the mechanism, showing smooth interaction between moving parts. To validate the structural reliability of our system, we conducted a static stress analysis using SolidWorks simulation. The simulation applied realistic operating conditions, including a 100 Newton normal force, 3 Newton-meter torque, and gravity effects. Different materials were assigned based on component requirements. The filter assembly used medium-high impact acrylic, while the hand wheel was modeled using A286 iron-based super alloy for durability. The analysis confirmed that the selected materials and assembly design can safely withstand operational loads without structural failure. This demonstrates that the unit is mechanically stable, reliable, and suitable for repeated field use. The stress animation highlights displacement behavior under load, helping visualize the system's structural response. To present the final concept, we developed photorealistic renderings and a real prototype of the unit. These visuals demonstrate the practical appearance, material selection, and usability of the design. The prototype validates the feasibility of our concept and bridges the gap between digital modeling and real-world implementation. In conclusion, the Solar-Assisted Mechanical Water Purification Unit offers a sustainable and effective solution for clean water access in challenging environments. It combines innovation, functionality, and environmental responsibility, while supporting SDGs 3, 6, 7, and 12. This project strengthened our technical knowledge, teamwork, and problem-solving skills. We sincerely thank Dr. Ayman Abbas and all teaching assistants for their continuous support and dedication throughout the semester. Thank you for watching.